Okay. Everyone, welcome. This is Steve Paff with the Weather Service in Wilmington, and also with me is Tim Armstrong, the Tropical Program Manager, and Mark Bacon, the Severe Weather Program Manager. And Tim is going to do the bulk of the presentation with the focus on some local hurricane history, and then we'll spend the last 10 minutes or so on the outlook for 2018. But we know you're all extremely busy, especially this time of year. We appreciate you taking the time out of your schedule to visit with us. So at this time, I'll turn it over to Tim Armstrong.
Can you minimize this out? All right, good morning, everybody. I'm Tim Armstrong, one of the meteorologists here at the National Weather Service office in Wilmington. I wanted to present a little bit of the really rich hurricane history we have here for the Cape Fear area, for southeastern North Carolina and the northeastern corner of South Carolina. Hurricane history here goes well back into the 1600s, where we have records and some of the early explorers of massive storms they would run across. It goes in waves, but we're going to talk about some of the climate cycles that we see that influence our hurricanes. Okay, this is since 1950. This is a tremendous number of storm tracks here. This is basically every named or numbered tropical system that has affected the Cape Fear area since 1950. It's 88 systems here. You'll notice the tracks generally come from the south or southwest, move across us. That's because the Bermuda High sits offshore, produces a clockwise turning of wind. That's our climatological pattern we see during the summer and early fall when the heart of hurricane season happens here. But you can certainly see there's a variety of tracks, a lot from the Gulf, a lot across Florida, a lot from the Atlantic that affect our area. All said, we get an average of about 1.3 systems a year that move close enough to bring some effects. That doesn't mean hurricane force winds, obviously. It just means you'll have rain, you'll have wind, you'll have some sort of impact, at least peripheral, from these storms. So certainly dealing with a tropical system is an every year event in this part of the country. If we localize it down just to named storms, in other words, tropical storms with winds of 39 miles per hour or more, we still average almost one a year that affects our area here in the Carolinas. And you can see again, we have a variety of tracks, some from the Gulf, some originating from the Bahamas and off in the Atlantic Ocean there. But since 1950, 61 storms have affected this corner of the Carolinas here. If I localize it further just to hurricanes now, this is winds of 74 miles per hour or stronger. 26 storms since the year 1950. That averages out to about 4 storms every 10 years roughly. And you'll notice now the tracks, we see very few tracks across Florida or from the Gulf. Most of these are storms coming up from the Caribbean, from the main development region off in the Atlantic Ocean. So certainly for our significant storms, they're going to bring larger impacts to the area. We're looking down to the south and southeast now. Category 2 storms, we're looking at winds in excess of 95 miles per hour. Still, we average about one every 5 years that draws close enough to our coast to bring some impacts to us. Category 3 is what we consider to be a major hurricane, winds 115 miles an hour or stronger. Those happen a little less often than once a decade for this portion of the Carolinas. And if we go to Category 4, these are the truly catastrophic storms here. We're looking at once every 2 decades roughly. And the few that are on this map here since 1950, we can probably even identify the names. These are all names that I'm sure most of us know here. We've got Hurricane Hugo that came up through the Charleston area back in 1989. Hurricane Hazel that hit near the North-South Carolina border in 1954. The 2 other tracks you see there, one you may have never heard of is 1958's Hurricane Helene, almost a Category 5 at one point. The winds were 150 miles an hour as it was east of Charleston. And also back in 1984, there was Hurricane Diana that did a funny little loop off Cape Fear as a Category 4, but then rapidly weakened as it moved inland there. I want to show you here Category 5s. We've never had one here since 1950. We've actually never had one confirmed in hurricane history. We're going to do everything we can to keep it that way. The closest we've ever come to a Category 5 in the Carolinas, we're looking back to 1899. There was the San Ciriaco hurricane, which was a Category 5 earlier in its life, I believe, moved over Hatteras Island, apparently overtopped almost the entire island with surge, and that's not something that's really happened ever since or before in our climate history there. So that would be the closest we've ever come to a Category 5, at least here in the Carolinas. We're going to look in detail at some of those really powerful storms of the past 70 years or so. Hazel, of course, 1954 is the last Category 4 storm to actually affect North Carolina directly. Winds were about 135 as it made landfall on the Brunswick County coast there with gusts up to 150. The big deal with Hazel, it struck at a high tide during a full moon, so you're looking at a worst case scenario in terms of water levels there. And we're told that a 12 to 18 foot storm surge practically erased Oak Island. Of the hundreds of homes that were already on the island, very, very few survived the storm. It pretty much erased the entire barrier island. Hazel was responsible for almost 100 deaths in the U.S., many, many more in the Caribbean, and it maintained its strength, oddly, as it moved up through the mid-Atlantic and into Canada, where there were still hurricane force winds from Washington, D.C. to New York City all the way into Toronto, Canada. So certainly a lot of folks remember this storm as one of the worst on record. Hurricane Hugo, actually an instrumental storm in my coming to a meteorological career, made landfall in Charleston. This was September 21st, 1989. Winds of 140 miles an hour. This was the last Category 4 landfall to affect the Carolinas directly. Storm surge reported as high as 20 feet near Bulls Bay, just north of Charleston there, and the damage in Mount Pleasant, McClellanville, and some of those coastal Sea Island communities was substantial there. Pawleys Island, we move up toward the Grand Strand there, still had a storm surge, 8 to 12 feet we're told, and actually because of the shape of the coastline, that storm surge was focused on up into Brunswick County as well. That concave shape to the coastline tends to focus higher storm surge values in there. And Hugo was a fairly large storm as well, so many, many piers and even some beach homes and businesses were destroyed across the Grand Strand up to Oak Island with Hurricane Hugo back in '89. And I mentioned this was instrumental in me coming to a career in meteorology. I lived in Hickory, North Carolina then. I was a 7th grader, and that's what my parents' backyard looked like after Hugo came through September 22nd, '89. We had hurricane force winds 250 miles inland, and I thought, wow, this is pretty neat. I'm going to study meteorology, and here I am today talking to you about this storm, but pretty substantial damage for sure. Fran in 1996 was one of our more recent direct landfalls of a major hurricane here at Cape Fear. Winds 115 miles an hour, and we had wind gusts over 100 actually measured on anemometers here on the coastline. Fran was responsible for over 24 deaths and $4 billion in damage, and it sort of started that hyperactive period of active hurricanes that lasted through the 90s. Piers on Wrightsville Beach were destroyed. Storm tide was up to 12 feet high. The bottom picture you see there is from Topsail Island. That's a picture provided by the North Carolina Department of Transportation showing the just immense damage that a landfalling Category 3 storm brings here to the coastal Carolinas. Fran is also responsible for producing the second lowest air pressure, barometric pressure, ever recorded, 961.4 millibars or 28.39 inches. We rank storms by how low their air pressure is. A stronger storm has a lower pressure, and in this case here, Fran is the number 2 storm on our list. And you might be thinking, well, what's number 1? Well, that's our very next storm on the list here, Hurricane Floyd, September 16th of 1999, just a few years later. People had just been repairing the damage from Fran, from Bonnie, from Bertha, the suite of hurricanes that affected the area all through the mid to late 90s there. And then Floyd comes through and produced the lowest pressure on record ever here. Wind gusts, again, 100 miles an hour or better near the Cape Fear area. Floyd is going to be remembered for its rainfall, though. Here at the Wilmington Airport officially, over 19 inches of rain fell. That's the most ever associated with a landfalling tropical cyclone here. And of course, just a couple of weeks before Floyd was Hurricane Dennis, which wasn't a great wind maker, but dumped 5 to 10 inches of rain, saturated the soils, and then when Floyd's rainfall fell on top of that, just all-time record flooding across most of eastern North Carolina, the Tar River Basin, down through the Cape Fear, northeast Cape Fear. Some of those crests are still certainly in the all-time 2 or 3, even with the more recent storms we've had. And the storm surge from Floyd was about 10 feet due to its just immense size there. And areas that have recently been repaired from Fran were now re-damaged yet again, unfortunately. If you go down to the little hot dog stand at Wrightsville Beach, you'll see on the wall there, the trolley stop, they have Hurricane Fran and Hurricane Floyd's storm tides marked on the wall there. That's my children showing off the storm tides there. If this building was here during Hurricane Hazel back in 1954, it was not, but the marker would be about 3 feet above Fran based on the records we have there. So we certainly have dealt with a number of intense storms in this part of the country. More recently, we had Hurricane Matthew just a couple of years ago. Not a particularly strong storm in terms of winds, and you can see that organization-wise, it did not present a amazing view on radar, But again, tremendous rainfall inland. In some cases here, we set all-time high river stages on the Waccamaw River. Cape Fear River again at Wilmington set the all-time record stage there that originated during Hurricane Hazel. Wind gusts, we saw wind gusts less than 100 miles an hour, but the rain made this just a tremendous storm that's going to go down in the history books for a very, very long time, it looks like. I'm going to talk about two storms that are near misses that we would certainly be talking about every hurricane season if the tracks have been just a little bit different. I mentioned earlier about Hurricane Helene back in 1958 here. It passed only about 20 miles from Cape Fear, so Bald Head Island, Southport. Actually, the damage there was worse with Helene than it was with Hazel, but we're talking about a very small geographic area. Most hurricanes, you think about Floyd, for example, when they move up as far north as we are out of the tropics, the maximum area of winds expands out, and you don't have that super tight core of wind right around the center. Well, Helene was very different. It maintained a very, very tight core of winds like you might see in a storm in the deep tropics. You think about Hurricane Andrew back in 1992. You had Category 4, almost Category 5 winds around the center, but only extending out a very short distance, and that's what this storm was like as it passed by the Cape Fear area here. So just in the Fort Fisher, Southport area, the damage was absolutely extreme. Here in Wilmington, we did have our highest wind gust on record, 135 miles an hour from that here at the airport, but I'm not sure about the equipment that was used back then. Some of the wind equipment would overestimate peak wind speed, so I'm not sure if that would actually be measured the same on today's equipment. But still, the storm was close enough. We had the 8th lowest pressure in Wilmington's history. Hurricane Diana in '84 is another close miss. It was a Category 4 as it passed very close to Cape Fear, but then did a loop and weakened substantially as it came in, but still 10 to 19 inches of rain fell. We had 14 here at the airport in Wilmington. The area was not nearly as built up in 1984 as it was today, so damage only $65 million. I'm sure if a similar storm were to occur today, it would be much, much more significant. I want to talk briefly about some of the climate factors that affect hurricanes, and we'll be looking at some of this specifically for our hurricane season coming up here. El Nino and La Nina, you hear a lot about that in terms of our winter rainfall, winter temperature patterns, but it does have a pretty large impact on the hurricane seasons as well. During El Nino, that's when you have very warm waters across the eastern tropical Pacific Ocean. We tend to have fewer hurricanes here in the Atlantic, and that's due to sinking air and strong wind shear that typically will develop across the Atlantic Ocean. La Nina, which is the pattern we had last winter, typically makes the Atlantic hurricane season more active. We see rising air and less wind shear across the Atlantic Ocean. And here's a graphic just indicating this was back in the 2015-2016 winter. We had a strong El Nino going on. This was a late season storm, Tropical Storm Kate in November of 2015. Strong, strong wind shear across this system here. Hurricanes, you hear the phrase that they are essentially heat engines. They survive on the heat and energy that's pulled from the ocean surface into the atmosphere, and they build a core of warm air around the storm. Well, when you've got strong wind shear, that core of warm air is spread out over thousands of miles downstream and doesn't really intensify the storm, and in some cases it can even dissipate a storm. So strong wind shear in this case here will weaken or sometimes even obliterate storms before they can form. So as we move more perhaps into an El Nino pattern later this year again, we'll be watching for impacts on our hurricane season should the pattern develop. My favorite climate oscillation with regards to hurricanes is this Atlantic Multidecadal Oscillation, sometimes abbreviated AMO. Essentially, it's a 30-year cycle of water temperatures across the Atlantic Ocean, and it varies on roughly a 30-year time scale. So you have roughly 30 years of warm water followed by roughly 30 years of cold water. The cycle repeats over and over again. Starting in about the mid-1990s, we went into a warm cycle, which seems to correspond or correlate fairly well with when Hurricane Fran and Bertha and Bonnie and Floyd and all the great storms we've seen in the Atlantic since then started. We're about 25 years into this cycle now, so we're probably getting fairly close to the end. And in fact, some of the latest satellite data does show that parts of the Atlantic are beginning to cool off now. But we do notice that during warm periods here, we have heat waves across the eastern United States. We see lots of hurricane activity. During the cold portions of the cycle, we see generally fewer hurricanes in the Atlantic. It doesn't end them entirely, obviously, but we see fewer. And also, the eastern United States tends to have very, very cold winters. Those with long memories may remember some of the epic winters in the 1970s and 80s we had with record cold temperatures and deep, deep snow across portions of the eastern United States. So it will be very interesting in the next 5 to 10 years to see if this AMO pattern does shift to cold, perhaps making hurricanes a little bit less common in the Atlantic Ocean. We'll have to see. A lot of questions about climate change. Is that affecting hurricanes at all? And two graphs shown here. The one on the left is basically temperatures across the entire planet, showing a warming trend since the pre-industrial times. And as you might expect, the ocean and the atmosphere touch each other. So if the air warms, the ocean is going to warm as well. And you might think, well, that's going to obviously cause a rise in the number of hurricanes. We have not really seen that, though. This graph here shows the number of hurricanes across the North Atlantic Ocean basically in that same time period. And by any measure, we're not seeing any sort of a substantial increase. In fact, if you look at the bottom red line there, that's the number of hurricane landfalls in the United States. It's barely budged at all since the 1880s. If anything, the trend could actually be slightly downward there. So interesting anomaly there that despite the fact warming sea surface temperatures are occurring, we're not seeing that reflected in the number of hurricanes. The strength of hurricanes, however, may be rising. This is a statistic we call the Accumulated Cyclone Index, the ACE index, which basically measures how strong hurricanes are. There is a slight uptick in this over time, but you'll also notice that you're seeing a wavy pattern on there that corresponds to that AMO index. So we're seeing during the periods of warm Atlantic Ocean temperatures, we see stronger storms, not necessarily more storms, but stronger storms perhaps. The one that I can say does have some certainty to it, though, is rainfall. We have noticed that in tropical cyclones, but even just in thunderstorms and wintertime rainfall patterns, we're seeing extreme rainfall events becoming more common across the world and even here in the Carolinas. We just look at basic physics and it tells us for a 1 degree Celsius increase in temperature, the air can hold about 7% more water. And you look at Hurricane Harvey last year, dumped 40 plus inches of rain over a much, much larger area than any tropical cyclone in history has. And it certainly does look like that heavy rainfall events are going to become more common in the future. So if climate change proceeds as we've seen so far, we may actually see a slight downward trend in the total number of hurricanes. Those that form, though, could become a little stronger, but we definitely think we're going to see a significant increase in heavy precipitation associated with these landfall and tropical systems, or just with your average afternoon shower and thunderstorm as well. We had a few changes from the National Hurricane Center in how we're going to handle hurricanes this year. They're not major, but a few of these changes include these time of arrival graphics they began producing in a test mode. They're now operational, so these are going to be produced with every storm. Basically, they provide a couple options in the screen for you there, where you can get specific timing of when your tropical storm force winds are expected to develop. You can choose a 10% or greater threshold, which is what we call the worst case scenario, or you can choose a 50% threshold, which is what we call the most likely scenario. That gives you an idea. When you think that when the tropical storm force winds could begin at your location. And a few other things the Hurricane Center is doing for us this year. They're going to be increasing the length of their hurricane force wind forecast by 12 more hours. So we'll be able to produce site-specific forecasts for the onset of hurricane force winds at a little bit earlier time than we could have before. The Hurricane Center also has shrunk their error cone based on the last 5 years of forecasts, where they've noticed their forecasts have gotten better, so the size of that big white cone you see on the forecast graphics is going to decrease. Storm surge watches and warnings that we've been doing in a test mode for the past couple of years are now operational as well. And our surf zone forecasts that we produce here at the local level are going to continue through tropical cyclones. So you'll be getting specific impacts on the beaches as we go into tropical storm or hurricane watches and warnings. In previous years we had discontinued those, but we're going to be continuing those through the events this year. That is all I had, but I'm going to turn the talk now over to Steve Paff, who has a few items to mention about this hurricane season specifically.
Okay, thanks, Tim. And you know what he mentions about the climate change, in particular, these anomalous rainfall events becoming more common. You know, since I've been in Wilmington since 1998, we've had 4 of these events, which we, on average, I would think we'd see every 100 or 500 years. So we're seeing an increased number of these devastating rainfall events. So it's been undeniable what our history has shown with that. And to get back and touch upon the El Nino, La Nina, so the ENSO phase, the El Nino Southern Oscillation, many of you have been through some of my presentations, know I like to show the last several years for each of the phases, just to show you the impact that ENSO does have, and that shear that Tim was talking about has on the number of storms. It doesn't mean at any phase that we can't have a devastating hurricane like we saw in 1992, an El Nino year with Hurricane Andrew being a Category 5 at landfall. But when we take a look at each phase, for the last 6 years, the last 6 El Nino years, we being in place during the summertime, we had 65 named storms, 28 hurricanes, and 15 major hurricanes. And a major hurricane is a Category 3, 4, or 5 on the Saffir-Simpson scale. And when we look at the last 6 La Nina years, the last one being the summertime 2016, there were 95 named storms, 48 became hurricanes, and 23 became major hurricanes. And when we take a look at the last 6 neutral years, the last one occurring in the summer was 2017, 102 named storms, 51 of which became hurricanes, and 22 of those had become major hurricanes. So what's going on with these neutral and La Nina years is an absence of that wind shear that we typically see across the Atlantic Basin during El Nino years. And one of the other trends that we see is during El Nino years is you see an active Eastern Pacific tropical cyclone season and lesser amounts in the Atlantic Basin, and vice versa for La Nina and neutral. So that's just one piece of the puzzle. Tim talked about the Atlantic multi-decadal oscillation. There are shorter-term trends, North Atlantic oscillation. There's also patterns with the Saharan air layer and the amount of dry air that can come off the continent of Africa. They all can impose some influence on the overall hurricane season. So there's bigger picture and there's smaller picture in the overall outlook that's considered by the Climate Prediction Center when they come out with their forecast, in addition to trends in water temperatures and other things as well. And when we look at the hurricane outlook performance going back to 2002, these are all the May outlooks. So like that forecast that just came out from the Climate Prediction Center, that's what would go into our 2018 analysis of the forecast. So when we look at the range in the forecast is that pinkish reddish color. The blue with the red cap is the actual number of storms. So last year there were 17 named storms in the Atlantic Basin, and the forecast was for 11 to 17 named storms. So they hit it on the higher end. Last year, or actually 2016, the forecast was for 10 to 16 named storms, and there were 15 named storms. If you go back and look over the past few years, there is some merit to this forecasting, but ultimately when it comes down to messaging, the thing that we want the public to focus on is that all it takes is one. So whether the forecast is for a below normal activity year or above normal, our focus has got to remain, given the risk that we have in the history that Tim showed you, we can't afford to take a year off regardless of what the forecast is. And I also want to note that on this chart, the EN represents El Nino, LN La Nina, and the N is neutral, so corresponding with the year. And you can see some neutral years were excessive, like 2005. We run out of letters in the alphabet. There were 28 named storms. We had to go to the Greek alphabet that year. Just a phenomenal year. Last year, above normal year, but also a very intense year with Hurricane Harvey, Hurricane Irma, and Hurricane Maria, all causing just incredible devastation. We really lucked out given the character of the storms that were in the basin last year. We were just fortunate they weren't steered towards our direction. And looking at the ENSO prediction, this is a very busy slide, but these are just several of the ENSO models plotted on 3-month composite chart here. So we were currently in a neutral there as far as the April assessment. And when you look at that starting point and all those models of different perturbations, different physics and dynamics involved and statistics that are used, the farther out in time, the bigger the spread. As a forecaster, we like to see consistency. And when we look at the time frame where we're looking at the peak of hurricane season, we generally have one out of those slew of models that is implying the La Nina could occur, the bulk of which were in neutral conditions. And then there are a pretty good handful in the weak El Nino time or aspects for July, August, September, October. So there's looking at this, we can say there's a high likelihood of neutral conditions continuing through the peak of hurricane season, but there's also a trend towards the possibility of El Nino developing. If it develops later in the season, then it could be very active with neutral conditions in place. If it develops earlier, that could potentially mute what we ultimately get with the number of storms that are expected to develop. So I'm sure many of you have already seen this graphic with the from the Climate Prediction Center. And basically, if we take the pie chart there, we're showing 25% chance of below normal season, 40% chance of near normal, and 35% chance of above normal. So I think an easy way to sum this up is we're looking at a 75% chance of near or above normal activity this year. And as far as the projections go, I think the 10-year running average is 12, 6, and 3. The current forecast for named storms is 10 to 16, so we're near normal, hedging above normal. The hurricanes near normal to above normal at 5 to 9, and of those, 1 to 4 could become major hurricanes. And as far as some of the considerations with this forecast that I know were mentioned in the Climate Prediction Center's media release and information is the questioning of whether or not the El Nino could develop in time to be an inhibitor, and how will the current near average sea surface temperatures change, and how will that come into play. If they get above normal towards the guts of hurricane season, then that ACE index that Tim was talking about might come into play more. It might impact the intensity of the storms, and still giving note to the fact that we're in an active AMO that's started around 1995, 1996. So with that, we just thought it'd be a great opportunity to touch base with everybody, talk about what new things are to expect for this year. Of course, we will continue to provide briefings that will detail the timing and the degree of impacts that we feel will occur with these systems. There's some new products out there I encourage you to become familiar with. So when there is an advisory out there, look at the arrival times. If there is a hurricane watch or warning, become familiar with the probabilistic storm surge as well. You don't want to be waiting to the last minute to learn about these things. And of course, you can always contact Mark, Tim, or me if you have any questions or concerns with any products that are issued, or just want to learn more about what is out there. Remember in our messaging to be as unified as we can. There's a lot of misinformation out there thanks to the double-edged sword social media plays. So just please beware what you share. Just because you can share things, don't. And where you do see a thread in social media going awry, please consider posting a credible link that can help end the misinformation that might be out there. So with that, I'm going to turn the phone back on, take the muting off, and see if you have any questions for any of us.
The conference is now in talk mode.
Okay, anybody, any questions?
Steve, can you email that presentation out?
Yes, we will email the presentation, and more importantly, if this records properly, we will send the link to our YouTube channel where this can be viewed as well.
Perfect, thank you.
Any other questions or comments?
Steve, Hank Whitley, Southport Marina. Just wanted to say again, thank you guys. This is valuable information, and your briefings are invaluable for us. Thank you guys.
You're welcome.
Bad informed, I'll echo what the Marina guys said. It's great to have we would not otherwise have.
Okay, thank you for the comments about the briefings, and any possible feedback we can have to improve them. You know us all by now that we're always looking for ways to deliver better service. All right, everybody, we do appreciate it. Thanks for your time and and your participation.
Have a great weekend.